Hey you guys. Alright, so welcome to Mod 180, Automatic Transmissions and Transaxles. We're going to go over Chapter 133 today, which is Automatic Transaxle and Transmission Principles. So we're just kind of going to go over the rough basis of how automatic transmissions actually function. They're completely different than manual transmissions. Manual transmissions rely on a lot of gearing, or I'd say a lot of gears and a lot more components. This one actually, automatic transmissions rely on oil pressure or transmission fluid pressure. So let's go ahead and get started. Let's talk about just the kind of the basic fundamentals for it. So we're going to start off talking about the torque converter, and then you have the pump which actually pumps the fluid through the transmission. We have a series of clutches that actually helps us engage into certain gearing and certain gears inside the transmission. So there are gears inside, but it doesn't rely on those gears to actually give you this certain ratio and the transition of power through the input shaft, or say the torque converter, throughout the transmission. So we're going to get in a little more in depth with that obviously throughout the module, but let's just talk about the fundamentals of how a actual transmission functions. So torque converter, this is probably the most important component. Without a torque converter, we wouldn't be able to have the disengagement from the transmission to the actual engine. A torque converter is made from three parts. The impeller is located at the transmission end, attached to the housing. So the impeller is going to be actually this section here. The turbine is located at the engine side and is driven by the fluid flow from the impeller and drives the input shaft of the transmission. The stator redirects the flow to improve efficiency and multiply torque. So the stator here is where we're actually going to be able to control the amount of flow going through, and also to have that separation between the engine and the transmission. The split rings help direct the flow of fluid and improve the efficiency of the torque converter by reducing turbulence. So split rings is basically like a vibration dampener. It's to help keep a steady flow of fluid going through. So as the torque converter rotates, there's a certain two sections that are actually separate. So one's spinning with the engine, the other's spinning with the transmission, or not spinning depending if you're stationary. As the portion that's attached to the engine rotates, fluid is actually being pushed through inside. It's basically creating pressure. That pressure is transferred through the fluid, which then gets transferred to the transmission. Think of it like a clutch that turns on and off automatically depending on RPM and how much load is actually being emitted into the transmission. Two fans can be used to show how fluid or air, in this case fans instead of automatic transmission fluid, can be used to transfer energy. If one fan is operating, the blades of a second fan will be rotated by the flow of air past the fan that is unplugged, causing the blades to rotate. So this first one is non-powered. This is the section that's attached. You can think of this portion as the piece of the torque converter that's attached to the transmission. This is the side that's attached to the engine. As these fan blades rotate, they're pushing air. Now, as they're pushing air, it's going to come across the blades on the other side of the non-powered fan, which then is going to cause this fan to rotate as well. Now, is it going to spin at the same RPM as this one? No, not initially. Now, due to the fact that pressure increase, yes, we can get this one to spin at the same rotation and also the same amount of force, but it's going to take a lot more energy actually being passed through. So instead of having air pass through, think of it as actually having fluid being transmitted through the fan, and then goes through the actual non-plugged-in fan or non-powered fan. The torque converter bolts to the flex plate, which is attached to the engine crankshaft and rotates at engine speed. When you see a torque converter, most of them are going to be actually placed, well, let's say most of them, all of them are going to be placed in the transmission first. When you're actually removing an automatic transmission, you have to disconnect or unbolt the torque converter from the flex plate. Instead of having a flywheel like automatic or manual transmissions do, we have what is known as a flex plate. Now, a flex plate is just a mounting spot for the torque converter. It's going to be able to bolt the torque converter to the engine. Okay, but in order to get it out properly, if we have everything lined up, we need to first be able to put this or attach it to the transmission first. So you're going to have an input shaft from the transmission. It's going to come in, it's going to engage in certain sections inside the torque converter, and this is then going to be bolted up. So you're going to make the transmission and the engine first, then you're going to go ahead and bolt the torque converter to the actual flex plate. The flat sections that are cut into the hub of the torque converter are used to drive the fluid pump. When inserting a torque converter into a transmission or transaxle, you need to make sure that the torque converter slides all the way into the actual transmission itself. Because if you don't, you're not going to be actually engaging in the pump. A torque converter spinning and providing movement of fluid, but not actually providing movement of the pump itself, can cause the pump to go bad and actually cause damage to the transmission. So when inserting the torque converter, you're going to slide it in, you're going to feel it engage, you're going to give it a spin. While you're spinning it, you're going to push too, you're going to feel it actually lock into the pump. It should be pretty flush all the way around the bell housing. So the torque converter is going to be here, the bell housing should be here. You shouldn't have really much of a gap. If you have too much of a gap, then you're not engaged all the way. And you can see these two grooves. So these grooves actually fit inside the pump, which then once the torque converter starts to rotate, it's going to start to turn that pump, which is going to provide the pressure inside the transmission to create our gear ratios and actually be able to apply clutches and disengage clutches. The internal splines inside the torque converter are connected to the splines on the stator support shaft and the turbine splines in the output shaft. So these series of splines are going to be engaged inside the torque converter itself. So one section is going to be grabbing onto here, one section is going to be grabbing onto here. This one's going to actually be going into the stator. This input shaft is actually going to be going on the turbine. Inside here, you'll see the small grooves where the pump is actually going to be engaged. This section here is actually the pump. Not only is it the pump, but it's also where you're going to have your sealing for the actual torque converter being inside. So when installing a torque converter, you want to make sure that this portion here is nice and smooth. If you have little gouges and cuts and nicks, it can cause it to not seal properly, or it can actually damage a brand new seal, which it eventually will leak as well. Torque multiplication occurs when the fluid leaving the turbine strikes the front of the stator vanes and is redirected back into the impeller. So as these portions are all rotating together, remember you got fluid moving in there, you got transfer of energy through the fluid. As the fluid comes in and it hits the front of the stator, those vanes is going to help transfer that energy to the portion that's attached to the transmission. Then that movement is actually going to help with the rotation of the parts inside the transmission itself. I know it's a little bit confusing at first. Trust me, I'm still not 100% on the grasp of a lot of things with automatic transmissions, but I'm trying to explain it the best I can. Especially due to the fact that we use mechanical movement, but we use a lot of transfer of energy through the fluid movement. So as long as we know how the fluid is actually being directed inside the transmission, then we can get a good grasp on the knowledge and the function of an automatic trans. A stator contains a one-way roller clutch which locks it from rotating in one direction, which allows it to rotate freely in the opposite direction. Think of it like a beach cruiser gears. As you're pedaling, you can actually stop pedaling and it's going to allow it to free spin instead of locking up in both directions. You guys have, remember the big fixie bike craze where whenever you're pedaling, the energy is always being transferred. The reason why we have this free spinning clutch is when you think about an automatic transmission, we don't have an actual clutch to be able to disengage and engage the transmission from the engine. This allows us to come to a stop and not have that transfer of energy from the engine to the transmission, which won't stall the engine out. So now we can sit at idle, not enough energy to move the engine or to move the vehicle, but just enough to where you can actually step on the brake and hold it and not kill the engine. When you think about an automatic transmission, when you let your foot off the gas, off the brake, the vehicle starts to roll. That's that slight energy that's being created by the actual torque converter rotating and actually sending energy through the transmission, but it's not enough to actually stall the engine out. An expanded view of a typical torque converter assembly showing the torque converter clutch. Now, all these portions here, unless you work in a shop that rebuilds torque converters, you're never going to see these. The reason why is this portion that's attached to the flex plate, this portion that's actually where the transmission input shaft comes in, all of this is enclosed and is welded up. So if you guys ever have a free torque converter and you want to see what's inside, you're not going to use it for anything, you're going to have to cut the welds off the impeller and the converter cover, but you can actually cut them open and then go ahead and pull it apart and you can see all the parts inside. I'm thinking about doing that with one of our torque converters we have here, just so I can show you guys. I'll do a little extra lecture on the breakdown of each part of it. But like I said, unless you're doing the rebuilding torque converters, you're really never going to see these parts separate. Torque converter clutch friction material is determined by the vehicle manufacturer to provide the needed coefficient of friction needed. For example, many older units use a paper type friction material because they are fully applied or released, whereas most newer units use a synthetic material such as Kevlar or carbon fiber because the torque converter clutch is pulsed on and off, therefore requiring more robust material for longer service life. So the torque converter clutch is what helps us engaged in, usually for an overdrive gear. Like I said, we have different scenarios and different, let's say, driving habits and driving, climates, and everything's going to be changed as far as temperature, as far as load being applied to the transmission and the engine. So we have different materials that we can use as far as something engaging and disengaging. Something with the newer style like carbon fiber and Kevlar, obviously these ones have a different friction coefficient, meaning they're going to grab a lot harder than the actual paper material. But when that torque converter clutch gets engaged, it's usually during overdrive, which means you're going to have a lot of torque. The torque multiplication is going to be a lot different than the actual, say, like first through fourth gear. When we talk about the types of the automatic and manual transmissions, you're going to see we have a different number set of gears. For manual transmissions, direct drive is usually fourth gear. That's the 1-to-1 ratio going from the engine through the transmission out the drive shaft. When we have a manual automatic transmission, third gear is usually our direct drive. So fourth gear is going to be overdrive for a manual transmission, fifth gear or sixth gear is going to be overdrive. So just remember, fourth gear for manual, third gear for automatic for our direct drive 1-to-1 ratio. A cross-sectional view of a pulse width modulator or PWM torque converter clutch. The powertrain control module pulses the control solenoid which controls the fluid flow to apply the torque converter clutch. Definitely want you guys to be reading up into this chapter. I know it's a lot different. It's a lot harder to kind of understand it, especially us not being in class. But we're trying our best, making the best of a bad situation. The gear selector is often called the Prendl switch. Prendl is actually short for park, reverse, neutral, drive, and low. Most vehicles have some sort of Prendl switch. It doesn't necessarily mean that those are the only gears. My truck actually used to have somewhat of this same scenario, but it had first, second, third, drive, and then drive, neutral, reverse, and park. So they're going to be usually in the same order as you work your way down. Obviously park, it's going to be, technically park is neutral, but what happens is inside the transmission, a lockout ring comes in and doesn't allow the vehicle to actually move back and forth. If you guys have ever had one with a damaged the Prendl lockout, what happens is you put too much force, especially parking on hills. When you park on a hill, you want to make sure you put it in park and you pull that parking brake. Because if you let it sit on that Prendl lock, eventually it starts to wear out, and you can see there's going to be a lot of movement when you're in park, and then eventually that rod's going to snap. Now you just have neutral. And is there a parking, if that breaks, are you going to have any sort of ability to keep that car stationary? No, it's actually going to start to roll back if you're parked on the hill, or roll forward if you're parked forward down the hill. So make sure when you put it in park, set your parking brake. That's why it's called a parking brake. You don't want to damage that Prendl switch. A typical planetary gear set showing the terms that are used to describe each member. You have your planet pinions, your sun gear, ring gear. Now, they call it a planetary gear set due to the fact of how it functions. You have your sun gear. Think of the universe. We have our sun. What spins around the sun? Correct. You have all our planets. As the planets rotate, they're also circling around the sun. So think of these as our planets. as they rotate around the sun, they're also spinning as well. So that's why we call it a planetary gear set, because it mimics it basically copies how the entire universe functions. You got your main sun or your main star, you got all the planets rotating around it as it circles around. Typical planetary gear set showing the planet carrier, which supports all the pinion gears, also called the planet pinion gears. So I know you're wondering, why are we talking about this section here? We utilize planetary gear sets in a automatic transmission due to the fact that depending on what we're going to be sending power through is what's going to be changing our gear ratio. So if we send power through the sun gear, it's going to change the gear ratio and cause the outer portion of the ring gear to start to be the driven gear. So if you use this as a drive gear, this will be the driven. If this is the drive gear, this would be the driven gear. So you can see how, depending on the transfer of energy, we can utilize this to actually create two different gear ratios. Maximum reduction can be achieved by using the sun gear as the input or the drive gear, holding the ring gear and using the planet carrier as the output. So now we can use this actual portion here will be the output rather than the ring gear. So we hold this tight, use the input here, send the energy out. So now we're transferring energy through the actual output, or the the planet carrier as the output. Minimum reduction can be achieved by using the ring gear as the input, holding the sun gear, and using the planet carrier as the output. So you see, now we're using the outer section here. We're providing energy here, and we're using this as the output gear, which then sends the energy through, giving us the least amount of minimum gear reduction. Reverse can be achieved by using the sun gear as the input, holding the planet carrier, and using the ring gear as the output. So that's actually how we achieve reverse, by holding this middle section here, using this as the drive, and then using the actual output, this portion here. Because it's going to be, remember when you have two gears together, one of them is going to be spinning one direction, one's going to be spinning the opposite. And that's how most of our forward gears are. But if we can have them spin in the same direction, so if this one spins like this, and this one also spins in the same direction, like this and like this, then we actually achieve our reverse gear. A Simpson planet gear set is composed of two ring gears and two planet carrier assemblies that share one sun gear. This one's a little different. Let me see if I can find a real image of it. A Ravenel gear set is composed of two sun gears, one planet carrier that supports two sets of pinion gears, and a single ring gear. I'm not going to get too in depth with these just yet, you guys. This is it's just more fundamentals. You know, what kind of components we're actually using for automatic transmission. One style of transaxle turbine shaft drives an input shaft through a drivetrain assembly. So we don't have this design here in the shop, where it actually gets transfer of energy through a actual chain. You think of like almost like a transfer case. We're going to be also going into four-wheel drive in this module. So this is actually automatic transmissions and four-wheel drive, but it actually utilizes a drive chain to actually transfer energy through the transmission. Another type of transaxle uses a chain to transfer engine and torque from the output gear sets to the differential assembly or the final drive. So it's another, instead of having the final drive gears attached directly through gears on this portion, what happens is you actually have a drive chain with two gears on each end, which then send it through an output shaft and then down to the final drive assembly. This is actually the differential, just like manual transmissions, where you have spider gears and side gears, and it sends the power down through the axles. The reason why we have this design is usually by construction and by the construction of the transmission itself, and also by clearance and space. So depending on which way the engine's facing, if we need to be able to get the power sent back to the section where we can actually have more room for the final drive, or if depending on, like I said, basically the placement of the engine itself. A cutaway showing a final drive assembly of the transaxle. So think of this just like the differential that we were actually talking about in the last module. If you guys are new to the program, don't worry about it. We're going to still go in depth with it. This gear is actually driven by a pinion gear, which is located in the back. And as this gear rotates, you have your spider gears and your side gears. The axles are actually attached to it. The axle is going to be over here. You can't see it. comes in and through, which then engages with this side here, which then engages with this side here, which then transfers the energy from the final drive through the axles to the wheels. I'm going to skip over that one. CVTs, constantly variable transmissions. These guys do not rely on gears. What happens is we actually have two different types of, it's a belt and pulley system. So we have two types of pulleys, or two sizes of pulleys. And what happens is those pulleys actually have the belt sit inside. So the belt will be sitting right there. As the rotation or the amount of energy needed comes across these pulleys, what happens is they get narrower and they get wider. What that does is when it gets narrower and wider, think of it as like if you have something in between your fingers, and I don't know if I'll be able to do it. Here's the belt. When you actually apply more pressure, and they come in, that belt's going to slide upward. So when that belt slides upward, it's actually going to get wider. So basically you're creating one gear ratio and then you're creating another gear ratio, and it's anywhere in between. So we're actually creating different gear ratios by expanding and contracting that belt by the amount of how much the pulleys actually contract and expand out. So obviously when they come inward, that belt's going to get taller. Now when it goes outward, the belt's going to get shorter. The belt actually stretches back and forth, creating the different gear ratios. So a CVT belt uses variable width pulleys and a special chain to provide an infinite number of speed ratios. So belt and pulley CVT. CVT belt construction, you have steel loops with an element in the pulley contact area. We don't have a CVT in here, unfortunately. But these belts look pretty cool. If you guys want to go on Google or see if it has a picture inside your Kindles in the chapter, look up CVT belt and pulley system, and it'll show you a blown out view of it and show you how the belts actually look. It looks like a steel snake actually, and it loops around, and that belt will expand and contract with the pulleys changing their actual width. The Honda CVT Power Flow Park and Neutral is showing you just a different design from Honda, but it's all the same concept. And location of the Honda CVT start clutch. So it's showing you when you're actually engaging and you're taking off. This clutch here is what engages and allows you to actually accelerate from a dead stop. When we get into the CVT portion of this module, then we'll go on a little more in depth with this. Like I said, I don't want to just overwhelm you guys with too much information right now. Let's see. So that's pretty much it for this lecture. It's just a quick little breakdown of fundamentals and the parts for automatic transmission. Trust me, it's going to get a little confusing for a while, but hopefully I can get you guys back to understanding it a little bit more. If you guys have any questions, please let me know. Text me, email, Instagram, whatever. But I'll talk to you guys later, right?